Hi, Professor. My name is Ching Kung Lin, and I am in Group 3. So I'm going to explain my code on question number 5. So the question number 5 is I have to create a multi-level sort. So what I think is I'm going to use two different sorts. So the first sort will sort the selection from will sort the selection when the size is bigger than 10. And in that selections, when it keeps sorting until the size become less of 10, then I will do another sort. Then I will also tie my spatial sort to this to this sort. So right now I'm thinking since we have going to use two different sorts, so two different sort I'm going to use the first sort is bubble sort, then the second sort will be um, bubble sort for linked list. That is the two sorts I'm going to use, and I will combine them to create a spatial sort. So right now, let us take a look at my code. So since we are going to time uh, the consumption of the function, consumption of the function. So I'm going to use this function. It's called time funct. The time funct is under the tablet class, so it will take any type of function. By the way, if you are going to calculate the running time of the function, you have to include this library. It's called char and also you have to use this namespace. If you are not going to use this namespace, then you have to code it at here if you are not going to use the namespace. So for in the time funct, I'm going to create two variables based under the data type auto. The first variable is begin, and I will tell the computer it's time to count the time before the function start. And after the function runs to the end of the last line of the code, then I will create the variable end, then tell the computer it's time to end. Then I will return the other variables, which is called duration time. The duration time is the end time minus the time of the beginning. Then I can get the running time of my my input function. So that is how time funct work. So next, since I'm going to use the bubble sort, so the bubble sort is here. I have my white paper. So this is how bubble sort work. So the bubble sort work is I have the bunch. I have a list of the random. I have a list with the random number. So the bubble sort is I will take a look at the first number, then I will going to compare the next number. If the next number is smaller than the first number, then I will switch the two position. That's why I have this sort function here. Sort function here. So the bubble sort will just keep sorting, keep sorting from the first one. If it's not switch the number, then switch the position, then start with the second number. The second number will compare the third number. If it's still smaller, switch and keep comparing until the last of the number. But this is not the end because we still haven't finished the sorting. So that's why we need to have the two for loop. To take care of the rest of the number beside the first number, because the first number I already can make sure this is the smallest number in this list because I just keep doing the sorting. So I will start the second pass. I will start from the second position and just keep doing this. So you can see the smaller number. We just keep pushing in to the front position. So in the end of so when I finish the outside for loop, that means I finish the whole work of the pass. Then when the outside for loop gets to the size, the end, then I know that I get the order sorted list in ascending order, which is here. So that is how bubble sort work. So next, we are going to take a look my second sort, which is I'm going to use the bubble sort for the linked list. So the bubble sort for linked list, because we are doing the work with linked list, so of course we have to create the class of linked list. We have to create the class of node. I have to create the node. You have to create the node will take the value, and also will have the one pointer, so the point to the next node. And then I also have to have the thing is called create a new node. The create a new node is they will take the value. They will take value, and I will just give a new node on the value. And also, since we are doing the bubble sort for linked list, so of course we have to have the swap function. But this swap function is different from this swap function, because this swap function they deal with the value, but the swap function in linked list they deal with the node. So instead of taking the value for this swap function is taking the parameter of the nodes. So they swap the nodes. So the next is create a linked list from the array. Because in my code, I will just have the array. I won't create a list. I won't create a linked list in my main function. So I have to convert my array to linked list. So that's why I have the function is called create a linked list from the array. So basically, let me take on my white paper. So basically, I would take, for example, my array is this, but they are only the bunch of value in the array. They are not linked list because they don't have the node on each value. So my create linked list from array is the purpose of my create linked list from array is to assign the node on each at each of the value. So for example, the first one. So for example, the one I would just assign the node 1, and the 2 I would just assign the node 2, node 3, node 4, node 5 until all of the value gets one node. So that's my create linked list from the array do. So you can see I have. So you can see I would take the array, then I would take the size because I have to tell my create linked array when to stop. Then I have the start point. This start point, why I have this start point, I will explain in later of my code. But right now, just remember, you will just take a 0 at the beginning because I will assign the node from the very beginning of the list. So for loop, if we just I will just start they will just assign nodes from the very beginning of the world. They will just keep moving the pointers and assign the nodes. So next is a bubble link list. So this bubble link list I will explain at here. So how does the bubble link how does the bubble sort for linked list work? So first of all, I would take a node. I would take the first node because before that I already convert. I already use the create linked list from array to give the array to give the each value of the array and a pointers, a node. I'm sorry, a node. A node. So right now, if I want to sort it, I just need to tell my function where is my first node, or where is my first node. So I just assign to point. I just take the nodes. Then also I take size. So I would tell computers where do we start to store, then when do we stop the size. So my first node will just take the input node. Input node is tell my computer where to start, and this store node I would start node because this store node I will use it later. So I will have to check the first condition. If there's nothing in the node, the first node is null. Is nulls. That means nothing in there. So I don't have to store. So I will just return and end the function. So if the first node is not the null, there's something in the first node, then I'll just start running the while loop. So I will just compare the first node, the value inside the first node. Compare the for loop point to first node point to for loop. For first node point to the next, the value. So for example, if this one, the one here is the first node. I'm sorry, I take this. I can. There's a picture. So if 5 is the first node, is the if this square is the represent the first node, then the first node point to value, which is 5 here. If I compare with the first node, this one is first node. It's next. So this arrow is next. Next point to the next node, which is here, this square. Its value, which is 1. if it's great than 1. So that means if 5 is greater than 1, what are we going to do? We're going to swap nodes. So we are going to swap this 2 square. Then their node will be swapped. Then my first node, if their node is going to start, then when the computer want to find the first node, what is the first node? The 1 will be the first node. So that means this one will, the node will be swapped. That means when the computer want to find the first node, it will just find 1 first instead of find 5. So when the first, then if they got swapped, then the first node will just change. And if the first node point to next is equal to node, that means if they keep swapping, then the first node will just become, if the first node point to next, which is this arrow, if they sorted to the last value. The last value, if there is a small, if there's a small arrow here next, point to no, point to nothing. There's nothing to point. That means I know there's nothing to sort. Then my first node becomes the store node. The store node, remember here, the store node I put in here will become my input node. What is my input node? My input node is the first thing. It's my first node here. So I will just go back all the way, go back to the very first node here, which is 5. And then I will sort this from 5. Then if I finish this whole while loop, that means I sorted everything and everything is okay. Then if my counted here is equal to size, I know it finished the sorting. So I will just break. So that is how bubble sort for linked list work. And next I'm going to explain how to combine the 2 array. So in my code, since I have 2 different kind of sorted, then I will use these 2 different kind of sort mass to create my spatial sort. Again, what is my spatial sort? My spatial sort, when the size is greater than 10, I will use the bubble sort. Then in that bubble sort, when it keeps sorting until the size is less than 10, I will use the bubble sort with linked list. So that's my sort. Let us take a look at the spatial sort first, because we will get to the combined 2 array. So my spatial sort is that, and so there's a couple of different conditions for the spatial sort. So if the first condition is if my size is 0 or less than 0, then that means there's nothing to sort, because you give me the 0 size or the negative size, nothing to sort. So I will just return it and call the function end. So the next, if my size is less than 10, if my size is less than 10, so that means I don't have to I don't have to use my spatial sort, because the spatial sort is when the size is greater than 10. So I will just code one of the side. I will just code this mass to sort any array that is less than that its size is less than 10. So for this one, if the size is less than 10, I will just use the proper sort for linked list here. But don't forget, before that you have to, because I was declare the array here. So if I want to use the bubble sort with linked list, I have to convert array into the linked list. So that's why I have to use code this function. So yeah, function. But so after that, I have to convert the linked list back to the array, because in my combine two array function, I will take two arrays to become one array. So that's why I have to convert my linked list back to the array again. So how do I do that? First of all, I will create an array that with the size. Oh, I'm sorry, I missed. I'm sorry, I missed. So for this, the less than 10, I would just create a node, then sort it. Then I'm fine. But the next, if my size is between 10 to 19, that means I have a sort of, that means I got a size that's greater than 10, then we'll use a bubble sort. Then rest of the number, which is the size, minus 10, then I will use the other sort, which is bubble sort for linked list. So what does that mean? Let me just write. So if I have one, two, I'm sorry, just use. So for example, if I have 1, 2, 3, 4, 5, all the way to 10, 11, 12, 13. So if I have an array that contains 1 to 13, so there's a 13 numbers in this array. So that means I'm going to use this condition. So this condition is, I would take the first 10, because when the n is greater than 10, I would do the first kind of sort. So for this, I would do bubble sort. The index for here is 0 to 9, right here. Then rest of the 3, 1, 2, 3. Here I will do bubble sort with linked list. So that's that. So that's why. And here the index on 11 is 10 here. So my bubble sort with linked list will just only take 10 number, and my bubble sort with linked list will take whatever size that minus 10 number. So that's why here. So yes, for this, my bubble sort is 10. My bubble sort will take the target size, the input size, and we just sort the 10 number. This is size of, I will pass the array and also pass the size. So I will just pass 10 because I was just going to sort the first 10. So next, the rest of number, I will going to use the bubble sort for linked list to deal with. Again, I'll have to convert array to linked list to do it. So here, remember we have the start point of as function create linked list from linked list. Where's right here? We have the start point. So this start point is just tell the computer where should I put the first node at array. So if you still remember the number that is here, so I will sort the 11, 12, and 13. These three numbers, I will use the linked list to sort it. I will use the bubble sort for linked list to sort it. And the index for 11 is 10. So that's why I have to create linked list from array. I have to start with 10 here. And this 10 is for is for all of the condition in here, because for the bubble sort, I would just take care of the 10 number. So here, after sorting, I also have to convert it to back to the array. Then right now I will get two array. So the first array is 1 to 10. The second array is 11 to 13. Then I have to combine these two array become my correct array. So I will call this combine two array here, which is I will take the first array, then I will put the total size, the target size, because this is the size of combined array. Then this is the size of the first array here, input array. And I also have to put the link array, which is the second array here. And also put the size of second array. So since we call the combine two array, so let us take a look at combine two array. What does the combine two array do here? So my combine two array would take the 1, 2, 3, 4, 5 parameters. So first of all, I have to create a combine array, and it takes the total size, because I have to fit the size of two array. Of course, I can just add the first size and two size. I can do that, but kind of forget. But anyway, so right now I need the three pointers to help me to track the array 1, 2, and a new combine array. Typo. Combine array. So yeah, I have this in my white paper. Let us take a look. So I have the array. I just take an example. So if my array 1 is 1, 1, 3, 5. Oh, by the way, this code is if I want to use this code, I have to store my array first. But which is makes sense, because I get this two array from after I doing the two different kind of stores. So of course I will get a two sorted array. So first of all, the array 1 is 1, 1, 3, 5. The index is 1, 2, 3, 0, 2, 3. Then my array 2 is 2, 4, 6, 8, 10. And my index is from 0 to 5. So right now I'm going to combine these two array with my code. So yeah, my array 1 is here. Then I will take total size. Total size is should be 1, 2, 3, 4, 5. So it should be 10. My total size is 10. Then my array 1 size is 4. Then I will take a second array here. Then my array secondary size is 6. So first of all, create a new array, the combine array to store my number. Then I need the 3 index to help me to track the arrays. So I is the pointer for track the array 1, J is pointer to track array 2, K is the pointer to track my new combined array. So if the I is point to the first one here. So here's I, and here's J, and here's K. So what does the first while loop means? So first while loop is if my I is less than array size. So if my I here is less than array size. So what is the array size of what's the array size 1 is 4. So that means the I will just keep running from 0 to 3 until it ends. Then my J is if the J is less than array size, array 2 size, which is mean the J will just keep moving until 5. So let's take a look at first line. The first line is 0 is less than 4, and also 0 is less than 5, and then 6. Yes, so get past. So we could take a look at if statement. Take a look at if statement. So if array 1's I, which is 0, is less than or equal to array 2 J, which is 0. So they compare the first number. The index is also 0. So first number, if array 1 here, so run value 1, if 1 is less than or equal to 2, yes. If it's yes, so then my combined array K, which is also index is also 0, will store the number from the array 1 because array 1 gets the smaller number. So it will just get into the 1 here, going to the combined array. Then my array 1, I get increment, so we just go to the next index, which is here. Then my combine the K pointers have to go to the next position because they both got they both got check number and also fill in the number. Then let us take a look at the next round. So next round if sorry, where am I? So next round if my yes. So next one my I now become 1. So 1 is still less than 4. So pass. So J is still 0, 0 still less than 6 to pass. So right now my array 1 I is become 1, so it's check here 1. If 1 is still less than 2, yes, still less than 2, so it gets into here. So okay, to get to 1, then my I move to here. My J still stay here, then my K move to here. So next if my I2 array 1 2 is 3. If 3 is less than equal to array 2 0 is 2. If 3 is less than or equal to no, so it will just go to the else statement, which here. So this condition is mean if array number in array 1 is not less than array 2, it would just when we will know the number in array 2 is smaller than array 1, then we'll just pass the number in array 2 to the combined array. So we just pass to here, here too. Then then my j get in will increment, which is j will to here. Then my case go also get moved. I give to here. Then we just keep tracking. And my I is still less than, you could surpass. So right now my I is 3. Then my next is to 4. If 3 less than 4, yes. So pass and get increment to here. Just to stay 4. And check if my phi here is still pass my phi. If my phi is less than equal to 4, no. So I will pass 4 to K4 and move K to here. Then J move to the next. So next, my I guess increment will become here. I'm sorry. So my I will be here. So my I will become 4, which is already outside of the, which is already out of the size of the array 1. So this condition won't fit. It will just keep going to I missed some code. It will keep going to here. Because we know there's a possibility that the size of 2 array. Oh no, there's no possibility. The size of 2 array is definitely different because we sorted the first size, because one of the size were definitely less than 10. So because the array 1 and 2 has to be sorted, and if so for this one, if array 1 has a longer size, then we just append the rest of the size in the combined array. No, but so we will go to the second while loop. If the array 2 has a longer length, which is yes, it's longer 2 is longer 2, more 2 than the array 1. So then I will append the rest of the number to the combined array. So what does this code? So if my j is less than array size of here, my j right now is here. My j right now is at position 2. 2 is less than array size is 6. 2 is less than 6. So they keep running. So you just keep running rest of the number in the array 2 and just store it inside the combined array. So what will happen? We'll just store all of this number inside array. Oh, yeah, I just make this thing. So yeah, this should be, I probably missed one step, but anyway. So yeah, then we just append the rest of the set, because there's the rest of the number already sorted. So I just append it. So 6, 7, 8, 9. Then I get my combined array, which is here, from the 2 different sides of array 1 and 2. Yeah, that's how my combine 2 array work. So yeah, so for my special sort, I just up to my second condition, which is size less than 19. So what if I got a size is greater than 19? So yeah, my condition. So if I have the size from 1, 2, 3, all the way up to 10, 11, 12, all the way to 27, 28. Yes. So for in this condition, I already know that my linked list, my bubble sort for the linked list will the maximum number that will be sorted by bubble sort for linked list is 9 number. So which means the last number from back to the uh, array will be sorted by bubble sort of linked list. If my size of array is past 19. So that's why I have this line code here. I will still take the input array, but my size is size minus 9 because I know the last 9 digits, the last 9 number will be taken care of by bubble sort for linked list. So from here to here, this is size minus 9 will be taken care by bubble sort, 9 digits. So here. So this is bubble sort here. My bubble sort with linked list. It's also I have to take the array. Then I would tell. Sorry. Then I would tell the computer to start giving a note at position size at -9 to create nodes. Then I code the bubble sort for linked list. Then I also have to convert linked list to the array. Sorry, I have to cancel it. Array, then I have to combine these two array that I just sorted by different sorted. So that was my that is my spatial sort. So let us take a look for the main function. So again, for the first time, I will just call what kind of size you want. Then I will create 3 different types of sorts. So first, 3 different types of arrays. So array 1, I'm just going to use for only sorted by bubble sort. Array 2, I will going to be sorted only by bubble sort from linked list. The array 3 will sort only by my special sort. Then I will fill out the random number for this 3 array. This 3 array will take the same random number. So here, I will time the bubble sort, running time for bubble sort. The second, since I will create a note, I will create a note here, and I don't want to write it into the function, so I would just I would so at this I didn't code the function func or the type func. I will just implement the code here instead. So here I will just start beginning the time counting before create the note here. then end of here. Then I can get the complete time of on with only using the bubble sort with linked list. Then last, I will just calculate the time consuming for the spatial sort. So before we going to discuss the time complexity, I just want to run in the code to that you see if this code is runnable. Be patient. Check times. My computer is my laptop is a little bit lag. So if I code the size 9, okay. Let me code the function again. Okay, it's smooth right now. So if I code the size 9, now we get the time for each function. So you can see the bubble sort is 5, only bubble sort is 6 is 14, the spatial sort is 18. Then if I just code it with different size, oh, like 900, here I'll still get the input. So if I call like 99,000 and 99,999, it's still runnable, but it just takes time. Okay, I think it's just take too much. So let me do 5,000 instead. Okay, the 5,000 is worth, but I believe 99,000 is will be worked too, but it just take time here. To keep my code neat, so I just delete all of the code that will print the numbers. But before I doing the video recording, I do run my code with the print numbers. So it's here. So just let you see that I do sort the numbers. So this is a successful code running at different size. The input is 9 and 50. So this is the size 9. I do sort the number with my sort mask. You can see the number is getting stored here. The first one here is the random number in my array, and after sorting 3 different stored masks, and this is 51. It's all sorted completely in order. Okay, so next I'm going to discuss about the time for each stored mask. All right, there's a time complexity. So the bubble store, the time complexity is the worst case is it's bigger and square because it takes the two for loops. So we know there's let's take the quadratic time. And also the time complexity for the bubble store is also ON2 because they just keep running the node. You survive, they just keep running a node and keep running a node. With the announcement that in each time the board is the one link close to the head for the list on until the board is equal to head. So the complexity is very similar to the bubble sort. It's also quadratic time, But if we run the codes with a very big size, so at the beginning, if we just run like run like 50, you can see they don't have so much. It's just like double time of the it's just like double time of the time. But if we run like 5,000, you can see the gap between bubble sort with linked list is much bigger than bubble sort. The gap of time is much bigger. So why is that? So I think the reason why the gap is so much bigger is because in my bubble sort, I have to before the sorting thing, I have to assign the node to each of the value. But in bubble sort, you don't have to. It just sorted the value anyway. But in the bubble sort for linked list, I get one more step to sort it. So before sorting for the value, I have to assign a node to each value. Then I can start my sort. So that's the reason. So I think that's the reason why the bubble sort for linked list took much time than the bubble sort when it comes to the bigger size, bigger size of the array. So but not least, let us take a look for the time for each stored mass. So for each stored mass I already run for like 10 times. Actually, it's more than 10 times. So the average of times for SS9 is small size. So bubble sort is 1 because it just sorted anyway, and the bubble sort with linked list is 4.5 average. The special sort is 4.5 as well. Why? Because in my special sort, if the size is less than 9, it will just use the linked list. So the time the time consumption is the same. At size at 900, the bubble sort is around like 4,800, and the bubble sort with linked list is around 8,600. It's almost the twice as twice as the bubble sort, because I think the reason is just what I said, is because you have to the bubble sort with linked list have to assign the node at each value. But for this, the special sort is much efficient for linked list because I use bubble sort to sort the almost 90% of the number. So of course, so from the 90% of the the number in the array, I don't have to assign the node, which means I can save the time from that when I use the special sort. So the size at 9,000. The bubble sort is around 700,000. Then bubble sort with linked list is around 1 million. Then special sword is it's almost close to the bubble sword because like I said, the knight I just drawed it nine nine number with linked list. So uh the bigger size the array is, the time of the bubble sword and my special sword will be much more similar because because my special sword is kind of like use the bubble sword anyway. So in conclusion, the for the time efficiency is my bubble sword is great than my special sword than my bubble sword on linked list. So that is my conclusion. Thank you.